Good afternoon, everybody. My name is Derek from Technoform, Asia Pacific, and today I'll be talking about designing safe and durable facades to ensure facade integrity of buildings. Today, we will be covering a few topics. We will first start off by revisiting the benefits of thermal bricks and wall-made spaces presented by my colleague Amidst in the previous webinar. After which, we will move on to talk about why safe use of thermally broken frame is important, as well as the durability of insulating glass. I will also talk about some of the standards which ensures durability and sustainability of ensemble frames, as well as insulating glass. Lastly, I will also share some of the tests and services that Technoform provides. Without further ado, let us revisit the benefits of using thermal bricks as well as wall-made spaces. Aluminium is widely used for windows, doors, and facades for its good mechanical strength. However, aluminium is also a highly conductive material with a thermal conductivity of 160 watts per meter Kelvin, which is 160 times higher than glass. With exposure to the outdoor environment and solar irradiance, heat is absorbed and transmitted through conduction, convection, and radiation into the indoor air-conditioned environment. Due to thermal bridging, substantial heat is gained through the frame, causing the indoor frame to rise above 50 degrees Celsius at times. With heat transmitting through the frames as well as the edge of the glass, there will be additional unwanted heat transfer through frames and the edge of the glass. This will result in the inefficiency of air conditioning, as they will need more energy to remove the heat. In addition, building occupants will also experience thermal discomfort as the heat from the frames will be emitted from the indoor frames. So how do we reduce heat gain through the frames and the edge of the glass? We can consider inserting a low conductive material between the aluminium profile to have a thermal debridging. Technoform thermal brick is made up of glass fiber that reinforces PA66, which is an engineering plastic with thermal conductivity of 0.3 watts per meter Kelvin, which is approximately 533 times lower than aluminium. This effectively creates a thermal debridging and substantially reducing the heat gain through the fenestration frame, ensuring better indoor thermal comfort. With a thermal brick as small as 15 mm, we are able to improve thermal transmittance by 35%, and as SHGC has a direct correlation to the thermal transmittance, we see a similar quantum of 38% decrease in solar heat gain. Looking at the curtain wall frame performance, similarly by adopting a thermal brick width as short as 15 mm, you will be able to reduce the U value as much as 66% and the SHGC value by as much as 68%. We see a larger improvement for curtain wall system because generally uninsulated curtain wall frames have a much poorer performance due to the large depth. Therefore, from the improvements seen in both window as well as the curtain wall systems, a thermally broken system should be considered when trying to improve the frames. Here are some project references where Technoform solutions are being used. Apple showrooms as well as their campus commonly use jumbo size IGUs that are about 3 by 14 meters. In Apple Campus 2 in North America, they adopted Technoform's wall-made spaces to ensure the IGU are able to withstand the long loading as well as having great thermal performance. CITIC Tower in Beijing, the tallest building in Beijing with triple glazing curtain wall, they have decided to use Technoform's thermal brick in the system as well as wall-made spacer to assist them in obtaining LEED Gold certification. Another project in Beijing with a vision of reducing carbon emission, Beijing International Airport, designed by Zaha Hadid Architects, also incorporated high-performance glazing in the complex steel grid roof structure. Lastly, the current holder of the Guinness World Record for the largest glass window with a height of 17 meters, Taikang Tower in Beijing also adopted Technoform's thermal brick and wall-made spacer. Closer to home, Port of Singapore Authority has selected Technoform solution from Super Low Energy Building SLEB Smart Hub, which is a database that is proven to assist in obtaining super low energy. The maintenance base is the first major building to be completed in the area with super low energy rating. As from the project references that I have shown, it is noted that the facades are getting taller and more complex. Glass are actually getting larger and heavier. Hence, there is actually a need to ensure that the facades profiles are sustainable and the glass are actually durable. Before I move into how to ensure the safe use of thermally broken frames and durable IGUs, let us first look at some of the reasons to why there is a need to ensure safe use of thermally broken frames as well as durable IGUs. As buildings get taller year on year, building facades are exposed to more environmental loads like wind as well as temperature change. When the frames are exposed to wind loads as well as temperature change, the frames as well as the windows will go through behavioral changes like bending as well as shearing. Traditional non-thermally broken frames are able to directly transfer the load from the external to the internal structure with ease, as the entire profiles is made out of aluminium. However, with the introduction of thermal breaks, the aluminium profiles of the facades are now a hybrid of two materials, aluminium as well as engineered plastic. Therefore, there is a need to ensure that the assembled profile is still able to perform mechanically similarly to a non-thermally broken frame. Glass might not contribute significantly to the safety of the building facade, but durability of the insulating glass are equally important, as failure of insulating glass will mean that it will no longer serve the intended design use and lifespan. For areas where the day and night has large temperature differences, the cyclic change in temperature will result in the pumping effect of the insulating glass. With poor design consideration, this will result in gas leakage from the glass as well as moisture penetration into the glass. As such, to ensure safe use of thermally broken system and durability of glass, standards are put in place to ensure that industry manufacturers are able to follow and ensure that the end products are safe and durable. There are many recognized standards globally, and today I'll be touching on EN 14024, which documents the tests and requirements for mechanical performance of metal profiles with thermal barriers, as well as EN 1279, which documents the tests and requirements for insulating glass units. EN 14024 provides the industry stakeholders and professionals the requirements as well as the tests to ensure that the design as well as the components selected are of quality and will be able to perform as intended. Before we delve into the standard, it is good to note that manufacturing processes are also important in ensuring the safety and durability of the thermally broken frame. Traditional frames are traditional frames are a complete profile, and when loading occurs, the profile will bend rigidly. However, with the introduction of thermal break to the facade profiles, the profile will be required to be mechanically fastened. If the profile is loosely fastened, the profiles will bend at different rates. However, with mechanical fastening, it will bend at similar rate, but this will cause shear loading as well as the possibility of deformation. Hence, the assembly process plays a part in ensuring the assembled profile has shear strength strong enough to withstand the loading. So in EN 14024, they actually focuses on the tensile strength as well as the shear strength of the assembled profile, as the external facade are in constant exposure to wind and temperature loading. This will cause transverse as well as shear stress. In addition, facades are supposedly designed to last a long time. Hence, there is a need to ensure that the assembled profile must be able to withstand the test of time. This is why there is a need for testing and elongation of the assembled profile, as well as the transverse strength after aging, which is simulated with 1000 hours. Tensile strength has to meet the requirements at room temperature, as assembled profiles needs to be well designed and manufactured. This is because the profiles will be part of the facade system and will be there for the design lifespan. Hence, there will be a need to also ensure that the assembled profile is able to perform equally well after the initial installation of the assembled profile. Hence, the profile are also placed through an aging process of 1,000 hours to simulate the building built for a long period of time. For climatic regions, there will be different seasons, and during summer, the temperature of the frame will be heated to high temperature, while during winter season, temperature might be reduced to possibly below 0 degrees. Therefore, the tests are to ensure that the assembled profiles are performing as per design mechanically at temperatures of 80 degrees as well as negative 20 degrees. As time passes with constant wind and temperature loading, it's also important to ensure that there is minimal elongation from the assembled profile, as elongation is undesirable. Hence, an deformation aging test method under loading is done at 80 degrees for 1,000 hours to ensure that there is less than 1 mm in elongation. In Technoform, we use materials that ensures that the elongation after aging is way below the requirement of 1 mm. As seen in the table on the slide, our thermal break profile as long as 24 mm has tested to have elongation less than 0.5 mm. Besides transverse stress acting on the facade system, longitudinal stress are also present due to the difference in temperature between the external and internal frame. As a thermally broken frame's advantage is to isolate the heat on one side of the frame. The heat trap, which might increase the temperature of the frame to as high as 80 degrees at one side of the profile, causing expansion, which might lead to shearing. Hence, there is a need for a test to ensure that the assembled profile is able to withstand the shearing effect. In EN 14024, loading is placed on two ends of the aluminium profile at a slow feed rate, and the measurement is actually recorded. As we have looked at some of the test requirements for EN 14024, some of us might have the question of how are we able to obtain the desired requirements as stated in the standards. In the next few slides, we will look at what raw materials Technoform uses, as well as processes that ensures conformity to the standards. After testing on different materials and combinations, PA66GF25 has found to be the ideal choice for thermal breaks. This hybrid material is a combination of polyamide 66 with 25% glass fiber content acting as the strengthening agent. Technoform not only uses long virgin glass fiber to ensure good mechanical properties, we also tap on decades-long knowledge and technology to be able to weave the long chain of fibers into the polyamide, resulting in excellent strength that meets and go beyond the global standards like the deformation resistance shown in the previous slides. Besides having strong elongation resistance, PA66GF25 is the ideal choice in terms of thermal expansion. As the frames are exposed to high heat conduction, there will be linear expansion occurring, which will cause tension between the thermal break and the aluminium profile. Therefore, a material is needed to have similar linear thermal expansion. With aluminium's coefficient of 25 times 10 to the power of -6 per Kelvin, PA66GF25 is only 10% different, which means that the variation in length during the thermal expansion is similar between both material, and it will lead to less stress on the profile. In comparison to aluminium and PVC, the thermal coefficient difference is 320%, which is so much more than PA66GF25, and it will lead to extra stress on the facade system. Hence, choosing the right composite material for thermal break manufacturing is crucial in ensuring a safe facade system. In the process of assembly, the proper execution of knurling, inserting, and rolling will ensure a good shear strength for an assembled thermally broken aluminium profile. Here are some of the examples of poor execution of knurling and rolling process. By selecting inferior quality of thermal break, cracks or even breakage might occur. In Technoform, we go beyond by supporting the customers by advising our customers the best practices in the assembly process so as they are able to meet the performance requirements. For facade system, which is the most exposed segment of the building, requires standards like EN 14024 to ensure that the facade is able to withstand the designed lifetime. Hence, with the right raw material, as well as the correct manufacturing process, this will allow an excellent assembled profile that will meet the requirements of EN 14024, which will in turn ensure the safety of the facade system. After discussing the EN 14024 that ensures safety of assembled aluminium profile, let us now look at another standard, which is EN 1279, which covers the requirements for insulating glass unit. As insulating glass takes up the majority of the window or facade system, we will need some form of evaluation that ensures that the parameters of the IGU, especially the safety portion, does not change significantly over time. So actually, EN 1279 are made up of 6 documents, each talking about different tests and requirements for each component of the insulating glass. But today's topic is focusing on durability of the insulating glass. So we will be talking more in detail about the product standard in 1279-5, which references the moisture penetration, gas leakage, as well as gas concentration test requirements in 1279-2, 3, and 4. So in EN 1279-2, they describe the test method of determination of moisture penetration index and specifies the requirements for insulating glass units. The average moisture penetration index has to be less than or equal to 20%. Moisture trapped in the IGU is something that we are unable to control, especially the manufacturing process is done in the open environment and in regions that are constantly humid. But with the excess moisture, this will lead to condensation happening within the glass. When the inner edge of the glass reaches dew point temperature, this will mean that the IGU has already failed, as it is unable to prevent condensation from happening. Hence, this test fluctuates temperature between high and low, creating the pumping effect caused by hot and cold climate temperature change. This will ensure that the IGU has a good sealant and to also check the moisture penetration. The picture on the bottom right shows what happens when condensation happens within the IGU, and the marks caused by the IGU, it's caused by condensation, will not be able to be removed without destroying the IGU itself. Checking the IGU to ensure that there is no gas leakage is also important, as gas-filled IGU increase the thermal insulation. And with gas leakage, the thermal insulation performance of the IGU will decrease. If I bring your attention to the purple dots on the slide, assuming the glass field is 100% at the beginning, the heat transfer coefficient of the insulating glass are the same at about 1.29 watts per meter square Kelvin. However, after 30 years, the IGU with gas leakage of 1% per annum will experience only about 8% increase in the heat transfer coefficient, like as you can see on the orange dots. But if we are looking at the black dots, the IGU with 3% gas leakage will result in 2 times the increase for the heat transfer, which is 16% increment in comparison to the original coefficient number. Therefore, we need to have a good IGU with good sealing, and that will ensure thermal performance of the IGU is built per design. So for gas leakage test, similarly to moisture penetration, the test also place the IGU in a fluctuating temperature to cause the pumping effect. And this will actually allow us to measure the amount of gas that leaks out after the test is completed. The 2 different types of tests in 1279 measures the moisture penetration as well as gas leakage, which will reduce the durability of the insulating glass. So how do we actually ensure that the moisture penetration as well as gas leakage is actually kept to the minimal? The spacer, together with the primary sealant, provides the gas seal as well as moisture barrier to the IGU. Warm-edge spacer not only provides excellent gas and moisture sealant, it also provides great thermal insulation properties at the edge of the glass as well. To ensure that the sealants and the barriers are good, EN 1279-4 Annex A portion talks about the requirements of having good glass to sealant adhesion. So in 1279 Annex A, the specimen are prepared with glass and sealant adhered together and is placed under a tensile machine till it is separated. This is to ensure that under loading, there will be no loss of adhesion between the glass as well as the sealant, which will cause moisture penetration and gas leakage. As Annex A in 1279 only talks about the adhesivity between the glass as well as the sealant, we should not forget that there is a possibility of moisture penetration as well as gas leakage if the sealant is not well adhered to the spacers. Hence, in Technoform, we take a step further to modify the adhesion test and test on the quality of adhesion between the spacer as well as the sealants. As mentioned in the earlier slides, we are moving towards the trend of having larger and clearer glass. This is why it's important to have durable as well as well-sealed insulating glass to not only prevent heat transfer through the edge of the glass, it is also to prevent moisture penetration that damages the inner coating, mold growth, gas leakage that will cause the insulating glass to not perform as per design. And this is why 1279 helps us in the testing and manufacturing of good IGUs. So today we covered standards that ensure the mechanical properties of assembled profiles with thermal barriers, which is EN 14024, as well as the standards that ensures the durability of the insulating glass, which is EN 1279. There are also other standards across the globe that also ensure safety and durability, like ASTM standard, as well as the AAMA standards, which I did not cover today. If you're unsure if your thermally broken window system will pass the EN 14024 standards, or unsure if your IGU are conforming to EN 1279, you can always approach us. So here in Technoform, beyond being a manufacturing company of thermal breaks as well as warming spacer, we also perform tests and services as well. With production plant distributed in 3 main areas, North America, Europe, as well as Asia, we are always near you in terms of supply. All our production plants and offices are ISO certified to ensure that there is no difference in quality of services received in any part of the world. In Technoform production plants, we understand that quality of product solution is paramount, as the solutions we are providing will be part of the facade that is designed to last many years. Hence, we do rigorous tests starting from the incoming raw material to the outgoing finished goods. We also do some tests in 14024 as well as EN 1279 on the production plants itself to ensure that we are providing solutions to our customers so that they can have a peace of mind and not worry if the assembled aluminium profile or the IGU will pass the actual standard verification. In addition, the competence center in Germany and laboratory there as well is well equipped and certified to do EN 14024 as well as EN 1279 tests. We also do have 2 training academies that allows us to bring awareness to the benefits of adopting international standards. As my presentation is coming to an end, I would like to highlight 4 key takeaways that I hope that you have gained today. With the demand for better performing facade as global temperatures are rising, we should not neglect the frame as well as the edge of the glass, as they are also able to transmit heat and they are the weakest link. With the introduction of thermally broken frames as well as insulating glass to solve thermal transmittance in the facade, standards like EN 14024 as well as EN 1279 are actually put in place to ensure the durability and lifetime performance of a facade. A durable facade not only look at the right selection of material, manufacturing processes are also vital in ensuring that the assembled aluminium profile will conform to EN 14024 standard, which in turn ensure durability and lifetime performance. Lastly, durability of IGU is not only the glazing. Technologies for edge bond are also critical in ensuring durability in IGU, like minimizing gas leakage and moisture penetration. The durability can be ensured by selecting a proven technology and material which conforms to EN 1279 standards. Like for example, a good sealant and spacer to ensure good adhesion for both the primary and secondary seal, which is crucial. So I have come to the end of the presentation. If there's any questions of project that you would like us to assist in optimizing your facade design using our technology, or would like to simply learn more about the company and what other solutions are able to provide, feel free to contact me with the details here on the screen, and we'll be able to set up a face-to-face meeting. If physical meeting is not possible, still feel free to reach out to me and we'll be able to communicate using other methods. Yes, and one more thing. We will be setting up a booth in Glasstech Asia in Singapore from 26th to 28th of October. So do drop by our booth at E07 Hall C if you are in the vicinity. And once again, thank you for your attention.
Thank you, Derek. Thank you for the very informative sharing of your Technoform's technology. Okay, without further ado, let me just kick off with the questions that we have from the audience. So one of the questions is that how is warm edge spacer different from aluminium spacer that we usually use? Can it be used in all types of windows?
Okay, so warm edge spacer is actually made up of co-extruded using polypropylene as well as stainless steel. So they have a lot of different kind of benefits to it. One of it is to actually improve thermal transmittance, because aluminium spacer actually has a thermal transmitter of 160 watts per meter Kelvin. So in this way, they are able the so-called double glazing unit, they are unable to prevent the heat from coming through the edge of the glass. So with a warm edge spacer, we will be able to prevent heat transmittance from the external to the internal, from the external to the internal. That is the primary role of a warm edge spacer, is to prevent heat transmittance either from the inside to the outside for hot regions like us, or maybe during the winter season is to prevent the heat from escaping from inside the room itself. But of course, there are also other benefits that Technoform warm edge spacer has, because Technoform warm edge spacer is actually made up of polypropylene, which is actually a resin. So we are able to do many different kind of colors. We can talk about black, white, gray, champagne. You know, unlike stainless steel, it's actually highly reflective. So many of the architects that we speak to, they are actually quite intrigued with the fact that our warm edge spacer is actually not reflective, and it's actually matte color. So they like it a lot. And also another thing is that we also, with warm edge spacer, because it's actually going through it's like glass, and then it goes through another so-called medium, followed by which it goes through another glass again. So in terms of acoustic, we are able to have some noise dampening as well. So yeah, that's the difference.
Thank you, Derek. So in that case, the warm edge spacer not only perform in terms of performance, it is able to meet different aesthetics needs as well.
Yes, that is correct.
Yeah, that is great. So, okay, we have another question for you, Derek. It goes this way. Structurally, can we calculate the aluminium profile using thermal break as one whole profile instead of having separate profile?
Okay, so to answer, just to ensure that I understand the question. So basically, the question is asking if they are able to calculate the aluminium profile using thermal break as one whole profile instead of a separate profile. Did I get the question correct?
I would think so. Maybe you can answer from that understanding.
Okay, so aluminium profiles structurally it is two different things, right? Because aluminium profile is actually is extruded using one whole entire profile. So the thing is, during the structure, I'm not an expert in structural calculation, because we specialize in thermally broken system. But in terms of the coefficient, the moment of inertia, it has to be calculated differently. So because as I mentioned before in the PowerPoint, one whole entire aluminium profile, when they experience loading, is actually rigid. Whereas once you have two different things, is actually considered a hybrid combination. So by mechanically fastening the process is actually to mechanically fasten the thermal break to the aluminium profile, and then this will give rise to a different kind of moment of inertia. But the moment of inertia has to be calculated separately from the traditional way of calculation. But in the EN 14024, they have actually listed out the steps for you to calculate in an event that the so-called the developers decides to use thermally broken, assembled thermally broken profile. So with that, you will be able to aid the so-called the designers to calculate the aluminium profile structure. Yeah.
Thank you, Derek. Okay, I think our participants are now all warm up and putting in the questions in the chat box, which is really great. So I see that there is a customer, Harry, that says that he has been using your system, and but he commented that, you know, they are very satisfied with the products and the technical team has been very helpful with their designs. But there are certain cases that their profile is very bulky due to EN 14024 requirements. So what is the usual or the range of the U capacity of thermal material used in your thermally broken profile?
Okay, so it all boils down to the U value of the fenestration or the design that they are trying to achieve. By using, like in my PowerPoint, by using as small as 14.8 mm, you will be able to improve the U value by about 38%. So I mean, there is actually, by using a thermally broken profile, a thermal break in the system, there's actually very minimal kind of increase in terms of the framing. So it will be, I mean, there will, by increasing, because what is happening is that the aluminium design has to be designed by the designer, and it also has to be decided by the U value itself. So the thing is, if it's bulky, I mean, they can always consult us, and we will be able to help ensure that the so-called assembled profile will be within their requirement. Yeah.
Okay, thank you, Derek. Okay, maybe one last question for you before we start the discussion round with all our speakers today. So, Derek, is the warm spacer called SP13 type? What is the good characteristic as compared to normal spacer?
Okay. So, I mean, warm edge spacer is a generic term that is used commonly in the European country. So the reason why why is it called warm edge spacer is because they are able to trap heat from coming through the double glazing. That's why it's called warm edge. Whereas aluminium is what they call it a cold edge lah. So there is a good characteristics, I would say, is thermal performance. Okay, as mentioned before. The other benefit, the other advantage is, of course, there is high level of design flexibility. Okay, and it also enables the bending. It also enables us to enable the so-called the manufacturer, okay, of the IGUs to have the ease of bending, because our SP13 is able to bend to a very small radius, and at sometimes it also allow customers to do negative bending as well, is to bend the other way. Yeah, so SP13 is able to use able to use in curved glass as well. So besides just SP13, we also have SP14 for customers that requires a little bit more rigidity towards the manufacturing of the DGU. Yeah, so of course we have also a wide other range of solutions as well, but feel free to come to my booth, then I will explain more in details.